Hello and welcome back to Engineering in Motion. Today we are kicking off a brand new playlist called the Arduino Python Pro Series. And in this first video, this preamble, I want to share with you a new way of working that combines the best of both worlds, the precision and speed of the Arduino IDE with the power and flexibility of Python. We are calling it Hybrid Arduino-Python Projects, and by the end of this video, you will understand exactly why this approach matters, when to use it, and how it prepares you for real-world engineering work. Okay, so let's get started. If you have been following my channel for a while, you know we already have a huge series of 30 lessons using Python and pyFirmata. That series is fantastic for learning, for rapid prototyping, and for projects where you want to focus on Python and not worry about the Arduino IDE. But as we've built more and more projects, I've noticed a common question. What do I do when a sensor needs to be read really fast? Or how do I get precise timing for something like an ultrasonic sensor, or something like rotary encoder? That's exactly what this new series addresses. Some systems simply require higher precision and speed than pyFirmata can deliver. So we are going to learn a hybrid approach that keeps Python at the center but brings in the Arduino IDE for the heavy lifting. Let's first recap what makes the Python plus pyFirmata approach so powerful. With that setup, you can easily control LEDs, buttons, motors, servos, and other modules and sensors that we have used so far in that series. You can do real-time plotting with matplotlib, which is amazing for visualizing sensor data. You can build, HMI dashboards and log data to files. All of that makes it excellent for education and rapid prototyping. You can test an idea in minutes, without ever writing a line of C++. That's why I love it. And that's why that series will always be relevant. But, this is a big but, there are limitations when you try to push beyond those use cases. The main limitation comes down to one thing: serial communication. pyFirmata sends messages back and forth over a serial connection, and that introduces unavoidable delay. The Arduino running Firmata can't handle microsecond level timing because it's constantly waiting for Python to ask for something. So if you're working with high-speed sensors like ultrasonic sensors that need multiple readings per second, or something like vibration sensors that need to capture rapid changes, the Python-only approach often falls short. And for real-time control, like keeping a motor at a precise speed or position, the timing just isn't accurate enough. So what's the solution here? We bring the Arduino IDE into the picture. But why Arduino IDE is needed? The Arduino IDE and the C++ code that we write with it lets us run real-time loops that execute with microsecond precision. The Arduino can read high-speed sensors accurately, generate precise PWM signals, and handle all the timing critical tasks that Python isn't designed for. And importantly, this gives us industrial level reliability. When you are building a system that needs to run for hours or days without a glitch, having the Arduino handle the low-level work is a huge advantage. Now, I want to be very clear. Python doesn't go away. It actually becomes even more valuable. In this hybrid model, Python is responsible for all the high-level tasks. like real-time plotting and visualization, building HMI dashboards, creating alerts, logging data, and performing, analytics. It can also still control, medium speed devices, things that don't need microsecond precision. So Python remains the brain, the user interface, and the data hub. The Arduino becomes a high performance, peripheral that does the fast and precise work. So let's visualize, the hybrid workflow. We write a custom Arduino sketch that reads sensors or controls, actuators at high speed. That sketch communicates with Python over a serial connection, the same USB cable you have been using. But now, instead of Firmata's, generic protocol, we design our own simple, fast protocol that sends just the data we need when we need it. Python receives the data, processes it, updates a plot, triggers an alert, or sends a command back to the Arduino. What's the result? So the result is that we combine the speed of the Arduino with the flexibility of Python, and that's the sweet spot. But this isn't just a hobbyist trick. This hybrid architecture is used in real factories and automation systems everywhere. Think about SCADA systems, supervisory control, and data acquisition. They often use a combination of programmable logic controllers, PLCs, running fast, real-time code, and a central computer running Python or other high-level language for visualization and data analysis. By learning this approach, you are preparing yourself for real engineering work. You are learning how to build systems that combine sensors, controllers, and monitoring software, just like in industry. So let's just take a concrete example, an ultrasonic distance sensor. In the hybrid approach, the Arduino runs a tight loop that triggers the sensor. It measures the echo pulse with microsecond accuracy and calculates the distance. It then sends the distance value over serial to Python. Python, in turn, plots the distance in real time, just like we've done, in the past. But now the data is far more stable and accurate. And we can easily, set up alerts in Python, like, for example, if the distance drops below a threshold, Python can flash a warning or send a notification. So, you get the best of both worlds. Accurate hardware reading and a beautiful interactive visualization. So, how does this compare, to the Python-only approach? With Python only, you are limited to sensors and actuators that don't require high-speed timing. It works, but it's not the right tool for every job. With the hybrid approach, you can support all types of sensors, fast ones, slow ones, digital, analog, just you name it. You get better accuracy and reliability, and you open the door to more advanced project possibilities like closed loop control, high frequency data logging, and real-time monitoring systems. So let's just wrap up with the key takeaways. So the first key is Python remains your tool for visualization, logic, and high-level control. Second, Arduino IDE gives you speed, precision, and real-time performance. The third one, hybrid combines the two, Arduino IDE and Python, to give you the best of both worlds. So by adopting this approach, you can build projects that are not only fun and educational, but also capable of industrial level performance. That's what the Arduino Python Pro series is all about. I'm really excited to dive into the actual code with you in the next video. We will start by building a simple, fast serial communication protocol, and then we will apply it to real sensors and actuators. So I would love to hear, your thoughts in the comments. Are you ready to go to hybrid? What sensors or projects are you most excited to try? Or if you have anything else to let me know, please leave it, in the comment section. And thank you for watching, and I will see you in the next video where we will write our first real code together.